Today we are going to discuss our third unit, that is exception handling. So what do you mean by exception handling? So what are the fundamentals of this exception handling? What are the different types of exceptions we are having? And so what are the keywords that we are using for this exception? That is what is try, catch, and then throw, throws, finally. And what are the different types of built-in exceptions we are having and how to create our own exceptions. So these and all we are going to study in this unit. Okay. So firstly, starting with this exception handling fundamentals. Before knowing this, we want to know what is an exception. Okay, exception is nothing but an abnormal condition. Okay, so we can say like exception is nothing but an unwanted event. So that is going to interrupt the normal flow of the program. Okay, so it is an unwanted event, so which is going to interrupt the normal flow of the program over here. So when an exception occurs, program execution gets terminated. Okay, so whenever this exception is getting occurred in our program, so our program execution gets terminated. In such cases, we get a system generated error message. Okay, whenever the exception occurs, program execution gets terminated. In that case, so a system generated error message will be displayed. Okay, so for overcoming this one, we are coming across with this exception handling. So what is this exception handling in this sense? So this is going to ensure that, okay, exception handling is going to ensure that the flow of the program so does not break when an exception occurs. So what I'm telling in the sense, if the exception occurs during the program execution in the sense, the program will get terminated, right? So to avoid that in between termination, we are coming with the exception handling. So this exception handling is going to ensure the flow of program does not break when an exception occurs. Okay. For example, if a program has a bunch of statements, okay, so and an exception occurs. So midway after executing certain statements, then the statements after the exception will not execute. Okay, and the program will terminate abruptly. Okay, so by handling, we make sure that all the statements execute and the flow of the program does not break. Okay, so if we are making use of this exception handling in the sense, in the middle of the program execution, it won't get terminated. So it will continue with the flow of the program execution. Okay, so generally we have to come across with the thing like what is the main difference between the error and then exception. Okay, so errors indicate that something severe enough has gone wrong. That means the application should crash rather than try to handle the error. So that is nothing but errors. So whereas exceptions are nothing but the events that occur in the code. Okay, so exceptions are nothing but the events that occur in the code. So a programmer can handle such conditions and takes some necessary corrective actions. Here, so if the exceptions are occurring in the program, in the sense, a programmer can able to handle that one. Okay, so by making some necessary corrective actions, so he can able to avoid this exceptions without the termination of our program. Okay, so that's why we are saying that exception handling in Java is one of the powerful mechanism to handle the runtime errors, so that normal flow of the application can be maintained. Okay, so to define this definition, first of all, we have to know what is that exception and what is that exception handling. Okay, exception in the sense unwanted event. So by this unwanted event, the normal flow of the program is getting interrupted. Okay, so to avoid that interruption, what we are trying to do, we are handling the exceptions. So how we are handling the exceptions? This is we are going to define this exceptions by making use of some keywords. Those and all I'll explain in next slide. But here, what we are trying to do. So exception handling is ensuring that flow of the program does not break when an exception occurs. Here I'm trying to say that when the exception occurs, the program execution gets terminated. No, so to avoid that problem, we are making use of this exception handling, which doesn't break when an exception occurs. Okay, so that is why we are saying that exception handling in Java is one of the powerful mechanisms to handle the runtime errors. Okay. So next, coming across with this advantages of exception handling. I just told you, right? So here we'll be coming up, going with the normal flow without any interruption. Okay, so we won't get any midway termination of our program. It will continue until the execution. Okay, next, it will be reporting some meaningful errors. Okay, so without any representation of severe uh, errors over here, so we will be getting some meaningful error reporting. That means whatever the issues that we are facing over here, that will be represented in this exceptions. Okay, so to handle all these exceptions, here we are having the mainly 5 types of keywords which we will be involved with this exception handling. That is try, catch, throws, and finally. So these are the 5 important keywords that plays a very prominent role in this exception handling. Each and everything we are going to discuss how we have to represent the try and how it will be utilized in our exception handling. Each and everything we are going to represent. Okay. So this is the general form of an exception handling block over here. So whatever the keywords that we are trying to represent, that will be mentioned over here. That is try, and catch, and then finally. Here I have used only the 3 keywords. And one more thing is for a single try, we will be having, we can also have the multiple catches also. Okay, so for a single try, we can have multiple catches also, or as a single catch. So depending on the situation, we are going to take the scenario. That means a single try with a multiple catch, or as a single catch. Okay. Next. So if you observe over here, try in this sense, here we are going to represent the block of errors. Okay. For this, whatever the things we have represented over here, we are trying to represent the exceptions over catch. Okay. So for a particular object, for a type 1 of object, we are going to represent the exceptions here in the first cache. So for the second type of objects, we are going to represent the exceptions in the second cache. Okay. So the representation of multiple caches is completely dependent on the program. Either we can represent the single cache or else multiple caches. It completely depends on the program we are going to represent. Okay. And finally, after handling all these exceptions, it will enter into the final block. So where it is going to get executed only after finishing all the try blocks. Okay. So if it has done with all the try blocks in this, then only it will enter into this final. Okay, so this is the general form of an exception handling block. Just we are trying to represent with the try first. Okay, so which will be included with the catch. Okay, either we can have a single catch or is one or more catches. Okay, and then after finishing this try block ends, then it is going to enter into the final. So coming across with these types of exceptions, okay, their object is nothing but a class over here. Okay, and throwable is nothing but a subclass over for object. Okay, and for this again the throwable classes we are having the error and then exception. Okay, so this throwable and objects are the subclasses only. For this subclasses we are having the errors and then exception. So just now I told you, right, error is nothing but a completely wrong representation. Okay, so the representation, that means the error might be a severe one or else might be a we can able to recover that one. It completely depends on the type of error we are having. Okay, so whereas coming to this exception. So just now I told you it is an unwanted event. Okay, so based on that unwanted event, so we are going to handle that exception over here. Okay, so based on that unwanted event only, we are trying to handle that exceptions by making use of the try, catch, throw, throws, and finally. Okay, so it has been mentioned, like if you see here, so these are the subclasses. Under this, we are having again subclass called error and then exception. So first I'll cover this error. Under this error, so we are having the virtual machine error and then assertion error. Okay, so where while inserting the values or else while running the program, so if it is not matching with the syntax or else if we are wrongly entering into the value of the type indices, then we will be getting this type of errors. Whereas coming to these exceptions, see, if we observe here, we are having the IO exceptions, that means input output exceptions, and SQL exception, and then runtime exceptions. Under this runtime exceptions, again, it has been categorized into arithmetic exception, null pointer exception, and then number format exception. Okay, so here we are having a various types of exceptions. If you come across with this null pointer exception in the sense when you try to use a reference that points to null, in the sense it is obviously an unwanted event, but that means if we are referring to a null value in the sense, it doesn't show any meaning, right? So that's why we are saying it as a null pointer exception. If you come across with the arithmetic exception, so, for example, when bad data is provided by the user, for example, when you try to divide a number by zero, any number by zero is an exception, right? Okay. So, dividing a number by zero is nothing but undefined one. You can't define that one. Then that type of exception is called a arithmetic exception. Any number that is divided by zero. Dividing a number by zero is nothing but an exception over here. So that type of exception we are calling like an arithmetic exception. Okay. So next are number format exceptions, in the sense if we are going to represent number format, for example, you are going to define the integer, but you are trying to enter a character type in the sense, then we can say it like a number format exceptions. Okay, along with this number format exceptions, we are also having the many types of exceptions which comes under this runtime exception, that is array index out of bounds exception, class cast exception. So we are having the various types of exceptions that comes under this runtime. Okay, if I take that array index out of bounds exception, in the sense when you try to access the elements of an array out of its bounds. For example, I have defined the array size as 5, but I'm trying to access the 10th element, in the sense it can't possibly, no. So in such cases, it will be throwing an exception called array index out of bounds exception. Okay, so likewise for each and everything, it has been categorized with its specific type of exceptions. If you are trying to refer the null value instance, it will be having this null pointer exception. If any arithmetic exception, like if we are trying to divide a number with zero, in the sense it is undefined, no, then those all comes under this arithmetic exceptions. Number format exceptions, in the sense if you are going to define the type of that specification as a number, and if you are wrongly entering into that values to the data in array size, in the sense, then again it will be throwing like a number format exceptions. Likewise, under this runtime exceptions only, we are having so many types of exceptions. Along with this runtime exceptions, we are also having the IO exception and then SQL exception. Okay, so we had to concentrate more on this runtime exception rather than this SQL and then IO exception. Why? Because here we are not making use of this SQL exception. So whereas IO exception, in the sense for passing the inputs and outputs, we need to come across with this IO exceptions. Okay, but more we are concentrating on this runtime exceptions and then IO exceptions rather than this SQL exception. Okay. See, whatever I have told you, so just I have given some points for that hierarchy. Okay, so all exception types are subclasses of all the built-in class called throwable. I told you, no, throwable is nothing but the subclass of tree. Okay, so it is a subclass of the object. Okay, so here, sorry, here again it is having two subclasses called exception and then error. Okay, so for this exceptional conditions, we are going to specify the catch. Okay, whereas for the address, it will be cutting under some normal circumstances. Generally, however, we are going to define a however we are going to recover an error, in that way only we need to overcome the errors. But here we are trying to handle only the exceptions. Okay, so our next concept is types of exceptions. So we are having majorly two types of exceptions in Java. One is with the checked exceptions and second one is the unchecked exceptions. Checked exceptions in the sense, a checked exception in any subclass of exception, excluding the class runtime. That means these exceptions will occur during the compilation time. Checked exceptions is nothing but these exceptions will occur during the compilation time. Okay, so we'll be having the two types of exceptions. One is with the checked exception and second one is the unchecked exceptions. So checked exceptions will occur during the compilation time, whereas the unchecked exceptions will occur during the runtime. So this is the main difference between the checked and then unchecked. Checked in the sense the exception will occur during the compilation time, and the unchecked exception in the sense it will occur during the runtime. Okay, so here coming to this checked exception, so here we should compulsory handle the checked exceptions in our code. Otherwise, we have to handle these exceptions. Otherwise, our code will not get compiled. Only whenever we are handling or else we are going to check the exceptions in this compilation, then only our program will get compiled. Otherwise, it won't get compiled. Okay, so that means we have to put the code which may cause checked exception in try block. So checked in the sense, they will check all the compile time itself. Okay, whatever the code, whatever the exceptions we are having, those all exceptions will be checked at the compile time only. Okay, I have represented, no, we are going to denote the exceptions in try and catch blocks, no. So that exceptions will be checked during the compilation time. If it's all okay, then only it will get compiled. Otherwise, it won't get compiled. Okay, so here there are two ways to handle this checked exceptions. We may declare the exception using the throws class, or we may use the try and catch block. As I already told you that, so we are having, that means we can handle this checked exceptions by making use of the throws class or else try catch blocks. Okay, so these are the keywords to handle the exceptions. No, try, catch, throw, throws, finally. Among these 5 keywords, so we are having the two ways to handle this checked exceptions. One is with the throws class and second one is the try, catch block. So we can use either of these two classes. Okay. So this is how we'll be handling this checked exception. Checked exception is nothing but which will be occurring during the compilation time. Okay. Next, coming across with the unchecked exceptions. Unchecked exceptions are at the runtime exceptions. Okay. So class errors and its subclasses are also unchecked. Okay. So this unchecked runtime exceptions represent the conditions that generally reflect errors in our program logic. Okay, and these cannot be reasonably recovered at the runtime. Okay, so this is with the unchecked exceptions. So is it that is, be clear with the differences between the checked exception and then unchecked exception. So we can vary these checked and unchecked exceptions with a single point called. So checked exceptions will be at the compilation time, whereas unchecked exceptions will come out at the runtime exceptions. Okay, so just like however we are saying that these checked exceptions will be handled by making use of either the throws class or else the try catch blocks. No, so here this compiler does not force client programmers either to catch the exception or declare it in a throws class in unchecked. So what we are saying that, so in checked exception, by making use of throws or try block, we can handle the checked exception, but not the unchecked exception. Okay, so here we are showing the two differences between the checked exception and unchecked. This is at the compile time and this is at the runtime. Here, by making use of throws and try catch, we can handle the exception, checked exception, but not the unchecked exception. So this is how we are differentiating the checked exceptions and the unchecked exceptions. So these are the two types of exceptions we are having.